In this video, we're going to learn how to find cube roots of variable expressions. But before we get started with any examples, it's important to note that when we're working with cube roots of variable expressions, there is never a need to be concerned with whether or not we need to add absolute value bars to our final answers, because cube roots are different from square roots. Remember, every positive number has two square roots, one that's positive and one that's negative. But cube roots don't work that way. If we're looking for the cube root of a positive number, that response must be positive. If we're looking for the cube root of a negative number, then that response must be negative. And if we attempt to change a negative response of a cube root to a positive response by putting absolute value bars around a variable, then we've made a grave mistake. So here's what we need to know. We don't have to worry about putting absolute value bars around variables when we're working with cube roots as opposed to square roots. So let's look at the first example over on the left. Notice that our instructions just say simplify. There's no need to distinguish whether or not our variables represent positive or negative values or both, because we're working with cube roots here. So we need to find the cube root of negative 125 x to the third. That is equal to negative 5x, because negative 5x times negative 5x times negative 5x is equal to negative 125 x to the third. Note again that when we're looking for the cube root of a negative value, the result is always negative. Let's look at the second example. In this example, we need to find the cube root of 216 thousandths x to the third y to the sixth. What number times itself again gives us 216 thousandths? That number is 0.6, because 0.6 times 0.6 times 0.6 gives us 0.216. What's the cube root of x to the third? That's x. And what's the cube root of y to the sixth? 6 divided by 3 is 2, so y squared is the cube root of y to the sixth. So the cube root of this expression is 0.6 xy squared. Let's look at the last example. Here we're asked to find the cube root of the fraction negative 8a to the third over 27b to the third. Well, what fraction times itself again gives us the negative 8a to the third over 27b to the third? We can find that fraction by finding the cube root of the numerator and then by finding the cube root of the denominator. The cube root of negative 8a cubed is negative 2a. And the cube root of the denominator is 3b. So the cube root is negative 2a over 3b. And again, absolute value bars are not needed because we're working with cube roots.